Yeah.
You could have probably done that for me. So the way the exam works is you'll get a note sheet, double-sided note sheet with anything you want on it. If you're uncertain what to put on there and you make one, I'll look at it and let you know, oh, you're missing some stuff that I would put on there. Happy to look at your note sheets and let you know if they're good or not. You can bring a derivative table. Probably won't need it, but you can bring a derivative table. There's one up in our world class. It's this math table that I put up in the resources in the content area. But you don't have to memorize all those for sure. And usually my exams, I shoot for 25 minutes if you know what's going on. So if you're like really on top of the material, you'll probably be out of here in like half an hour. And then if you don't, you got a little extra time. So you might be shocked at how chill my exams turn out to be. Okay, let's get rolling. Let's keep on rolling. I got a lot of stuff I need to get to by tomorrow to get that in order. Derivatives so far. So we've got our function, f of x. We've got our derivative, f prime of x. We've got x to the n, and x to the n minus 1. That's the power rule. We have got e to the x goes to e to the x. We've got a to the x goes to natural log of a to the x. And we've got sine and cosine. So we've got the derivative of sine is cosine, the derivative of cosine is negative sine. And we're gonna add to this table today because we know there's more trig functions than that. We also know the product rule. So if I have f of x times g of x, I've got the product rule. And I've got the quotient rule, which is f of x over g of x. This is all stuff I would put on my table, my handwritten table, even if I already had a derivative table. I would write this stuff down just to practice. Quotient rule. So let's get a couple other trig functions knocked out. Let's do tangent. Now we can build everything from that table over there that we're going to need today. It's pretty cool. We don't need to get deep because I can write tangent as a quotient. How do I write tangent as a quotient? What is tangent is equal to what? Over
Sine
what?
over cosine?
Sine over cosine. So this is the derivative of sine of x over cosine of x. What rule do I need to find that derivative? Quotient rule. Can we practice that right now, please? Let's find the derivative of this. And then if you want to get really fancy, you can simplify it.
I'm actually gone all of next week. Like I will leave for soccer on Friday.
Oh, do you?
Yeah.
Oh, so you'll be gone anyway. Oh, okay. But you were trying to just like be kind to your classmates, I know.
Yeah.
I think everyone appreciates the suggestion. I will contemplate it. Maybe you prefer it on the day when you didn't have to go to a game though. First thing I would do is, especially if I'm new at this, is to write things out slowly. Literally writing out the quotient rule.
question, you got any cool identities you can maybe pop out?
Let me put a couple things up that might be helpful. Yes, you may or may not remember that. At some point in your life, I'm sure you saw it. That's a great identity. In particular for this problem. What did you say?
It was on tip of my tongue.
Yeah, I saw it. I could tell. I could tell. Derivative of sine is cosine. Derivative of cosine is negative sine. Notice how there's really not actually a lot of thought on linking rules. I've got a derivative of a quotient, so I use the quotient rule. When I write that out, it tells me what I need to grab off the table. Derivative of sine, derivative of cosine. Those are things that are given to me. So I just plug in stuff in here. I get that. And now I'm just gonna simplify a little bit. Is there any questions over anything I'm doing up there so far? Looking good? Okay, cool. And so this top here this is a great identity. It is the queen of all trig identities. You can do a lot with it. This is just 1 on top. 1 over cosine squared of x. And I'm going to rewrite that as 1 over cosine of x squared, so we can just think about it. What's 1 over cosine? What's another name for that? Secant, AKA secant. So secant is just a fancy word for this expression. The secant of x, so that is secant of x, is 1 over the cosine of x. What's 1 over the sine of x? Just so we have a cosecant. So that's CSC of x. That is cosecant. So they're just fancy words for these things right here. What is 1 over tangent? Cotangent. It's cotangent. So this is actually secant squared, and that's our formula. So the derivative of tangent is secant squared. We can add that down to our table over here. Tangent and secant squared. Now, you might be getting scared that we're going to do this for all the trig functions. You don't want to see that. I can tell you that similarly, we could find the derivative of cotangent. Because cotangent is 1 over tangent, which means it's cosine over sine. And I could do the same thing with the quotient rule. It turns into, you get a sine squared in the bottom, like a 1 over cosine, you get negative cosecant squared of x. So there's a negative here. These are things that people often screw up with the negative signs, so just keep an eye on them. Derivative of cotangent is negative cosecant squared, derivative of cosine is negative sine squared. Just wanted to get those out of the way. Now we can do every trig function. Let's do a little bit of practice putting some of this stuff together in one problem that I'm going to beg you to move slowly and carefully on. So let's practice with the derivative of sine of x over 1 plus the x times the tangent of x. I'm going to read this. Now, if you're not sure what to do, watch how I read it. There's a quotient. So first off, there's a quotient here. I will need the quotient rule. To take the derivative of the bottom, what rule might I need? Product rule. So when you do the derivative of the bottom, you're going to need that product rule in here. So this one uses both quotient and product rule. So first thing I would do is write it out with the quotient rule. That's the most obvious part. When you zoom back, it's a quotient. So write it out. Leave the bottom alone. Top left alone. Times the derivative of the bottom. See how awesome the technology writing stuff down is? Now I've got smaller problems to do. And that whole bottom just gets squared. And you're just going to leave it like that. Now you can proceed. I just wanted to make sure we were off on the right foot together. Put a little note to remind you that's going to need the product rule. Oh, so Addie, you'll be gone Monday.
I'll be on like Friday.
Just Friday, and then the next week too, or
No.
just the weekend? Okay, cool. Okay, awesome. Oh, good. That's good. Gotcha. Do you want me to give you a refresher? Okay, I thought so. That's why I stopped by, just to visit. All right. So for first, before we go, there's that one. What's the derivative of the one? What's a constant? What's the derivative? There you go, cool. So 0 plus, now we're gonna product rule this sucker. Okay, does that make sense? Awesome. So when you have a product, you take its derivative, everybody just gets a turn and you add all those together. That's the best way to remember it. So I'm gonna take the derivative of x. Just let's write it out. Let's write out x here so that when you look back. Oh no, I thought what you wrote was great, but just write in x. Yes, ma'am. And then times tangent of x. So now the x has got its derivative plus. Now we leave the x alone. Times the derivative of the tangent. Put a ddx in front so you remember. See how now I remember. Oh, I gotta do that. What's the derivative of x? It is by itself. That's good. You're yes, you're doing great. You're like steering yourself out of a nosedive. No. It's a power rule. So look at that top rule. What's n?
Oh, okay, so it'd be like, which is.
Yeah, that's great. Which is x to the 0. And what's x to the 0?
1.
Oh, damn. So many awesome saves. I love it. Yes, ma'am. Then copy that down. Yeah, just times tangent. Don't even need to do anything. Plus, yeah. And then what's the derivative of tangent? You just look that up and take it. We just did it.
Yeah, cosine, or sine, yeah.
No, look in the table.
Oh, wait, no.
You're looking at the work
Oh,
for it,
yeah.
but what's the,
Okay.
in the end, you just need that.
Okay.
That's the good stuff. Oh, no. Can you see that table or is it hard to read?
Oh, okay, I see.
See, it's tangent, derivative of tangent is what? There we go.
Yeah.
Yes, ma'am.
So then it's just like, you leave this,
Uh-huh.
or you leave.
Just put the x in front,
Okay.
yep, and then, yeah, plus that.
Oh.
Yeah,
Okay.
and the one you don't even need to write, but yeah, it's cool, it's good, you don't have to
So
erase
in
it.
reality, it's like 10 plus X.
That's a fine reality.
Okay.
Yes, ma'am.
All right.
Beautiful, well done. Who needs a boost? Anybody need a boost? Oh, you're doing great. What are you looking? What are you thinking about right now? What part are you on? Cool. You're doing great. That's beautiful. Nice. Now the derivative of tangent was that guy we just created. It's hard to see. Well, I can't see crap. It looks terrible. Secant squared. With a little 2, right? Yeah. There you go. Otherwise, it's beautiful. Feeling good about it? Yeah. Let's see. Oh, you're doing some fun. Oh, I like, you're getting fun with it. You've already done the work, now you're doing math joy. Yeah, that looks great. That looks great. Yeah, I don't know if I just made it up, so I don't know if anything cool will happen, but I appreciate that you're working on it. Good. So good. Beautiful. Did you like it? Sorry. Let's see, so you got yeah, times that guy. Yeah, that's beautiful. Well done. It doesn't look beautiful, but you did it beautifully. It's a pretty atrocious problem, honestly. That's why Sam's suffering. Yeah, you did great. That's about as good as you can do with it. Joshua was trying to make it look nice. I don't think
I'm trying to figure out.
Oh, there's nothing to do
I was
with
about to
that.
say there's nothing.
There's nothing to do with that.
That's my final answer.
It's a beautiful final answer.
It's my best.
If your final answer looks like shit, then you did it right. Probably.
Alright.
Yes.
Can they use the,
For this guy, I would make it a little easier. No. First, I would rewrite it as x to the 10th over x plus 14 over x. So I break it apart first. Mhm. 14 over x. Then I'd simplify. That's x to the what? Yeah. Then that's x to the what?
yeah, thanks.
What power? So it's 14 times x to some power. I've got to go do this one, but you're on the right, that's right, you're on the right track. So let's see, let me just knock this out. This is cosine of x, 1 plus x tan x minus sine of x. 1 derivative of 1 is 0. Derivative of this guy, I'm going to use the product rule. Take the derivative of the x, which is 1, times the tangent left alone, plus, so this right here is going to be my product rule, this whole little chunk, plus the x left alone times the derivative of tangent, which is secant squared, all that over that, and there's unfortunately nothing else that can happen here. And I checked, I did, Kyle, I didn't look at what you were doing, but you feeling good about it? Okay, cool, awesome. A little unpleasant, sorry. That's what happens when I make shit up. Let's move ahead and just get the last rule out of the way so we can just be practicing with it up through today, Friday, and Monday. So our last rule, and this is probably the hardest rule. What's that?
That's always good.
Isn't that good? Yeah, that's not, maybe that's not, mine's the right line of work. I shouldn't be saying this kind of shit to people. So, last rule is the chain rule. And this is the one we're gonna practice, not chair rule, the chain rule. So the chain rule allows us to take the derivative of a composition of functions. And frankly, this is why it's so miserable for people, because I have learned over a gajillion years of teaching that composition is not something everybody has a great understanding of. So we're gonna practice it a lot. So the way to do this, so the way I read this is f of g of x. This word of right here, when I see these parentheses, so notice here, this is a parenthesis. When I read a parenthesis, I'm reading the word of. Anytime in math, for the most part, especially in this class, when you see parentheses, think of here. This isn't times. That's the key part I'm trying to get across here. That's not multiplication. First, I take the value x and give it to g. G spits out a number. I take that number and I put it into f and get out another number. So there's this x goes into g of x, and then I plug that into f of x. So there's two function evaluations here. And the way I do this derivative is I take the outside, leave the inside alone, times the derivative of the inside. I'm gonna write that out. So this equals derivative of the outside with inside left alone, so inside untouched, times the derivative of the inside. So you do hit each piece. The hard part is going to be identifying those pieces. Let's get a new color. So, some examples. Let's get some nice simple examples and things I would put on my chart because they occur over and over and over again. So let's do some common chain rules. Oh, that green is terrible. I bet that's really bad over there, isn't it? Yeah, sorry. Let's get a better color. Black pen might be nice. So what this says, Jasmine, is this says, I'm just gonna write it again, common. Does that look better already? If I turn the light on, would that help?
I can see it.
You can see it?
Yeah.
Okay. Common chain, I keep writing chair, rule, occurrences. So the first one is I've got to take a derivative of the sign of some multiple of x. So here k is a constant. All the time. Literally, one of the things I've taken the derivative of more than ever in my life is sine of some multiple of x, cosine of some multiple of x. So here the outside is the sine. Notice how I read this. This is sine of k times x. That's how I'm reading that. Here's the of. That tells me it's composition. These parentheses tell me it is composition. So the first thing I do is I take the derivative of the outside part. Think of peeling an onion. We're peeling an onion from the outside to the inside. So the derivative of sine is cosine. And I'm leaving the middle alone. Notice I just took a derivative of the word sine. Left this part untouched. So this is the derivative of the outside. This is the outside. Times the derivative of the inside. So this is derivative of outside. This is the derivative of the inside. And now, what's the derivative of k times x? K, solid. So I'm just gonna put that out in front. This is k times cosine of kx. That's a great thing to add to your table. So here I've got my function, sine of kx. Oh, this is a much better pen. And then the derivative of that is k cosine of kx. What about cosine of kx? Let's see if we can maybe think it through. What's the derivative of cosine? Negative sine. Leave the inside alone, times the derivative of the inside, which is k, because we just did that. So this is minus k sine of kx, if I'm rewriting it. This is also totally fine. Let's do a tricky one that's hard to see the composition. If I have e to the kx, so this is a tricky thing, because this is hard for people to see as an outside and an inside. But if I write it like this, the exponential function of kx, so right here I'm using computer programming language, essentially. Exp of something is just e to that something. Anybody in here code? Do some coding? Anybody ever coded e to some power? Okay, well, if you did, that's how you do it. You would use exp. This is called inline notation. You don't have to worry about exponents or anything. So here the outside is the exp function. This is the exponential of kx. Using our new notation, what's the derivative of exp of x just by itself?
E to the x.
E to the x, because this is just e to the x. This is a fancy way to write e to the x. So as Addie said, and then we'll just use that notation. Just different notation, that's just this and this. Just not a familiar one. So here, the derivative of the outside is exp of kx times the derivative of the inside. Well, we've done that, I'm gonna write it out, but that's just k e, yes. And that is k e to the kx. Let me show you a fancy form here that's gonna pop up. If I have e to some other function, so now we're going to think about that. If I ask you, what is the derivative of e to some crazy ass function? So this is derivative of exp of that crazy ass function. Outside is exp, leave that alone, or take the derivative of the outside, leave the inside alone, times the derivative of the inside. Derivative of outside, derivative of inside. And that's just, what is that, Sam?
The f prime of x times. Yeah.
Times e to the f of x, yeah. So this is another great rule to have down because this will also occur many times. Let's practice this stuff before we get further. Because honestly, we've got a lot already. We've got quite a bit going on, and this is a great place to stand and practice. So let's take the derivative of e to the sine of x. You got the formula right over there. Get used to using those formulas, and then the more you use them, you will use them a lot, they will become ingrained. We're using this guy right here. Good. Derivative of the exponent. All I'm doing is bringing the exponent's derivative out front. And that's cosine of x e to the sine of x. All right, let's try another one. What is the derivative of x squared times sine of 3x? Notice how I said it. There's times. Write the product rule out if you're not sure. Make smaller problems for your brain. First step up here in case you're uncertain or you just want a sanity check. Your own work, you might want to just get used to maybe notating so that if you ever look back at it, you'll remember. did. Oh, that's nice, that's a nice simplification. It's good to have people that appreciate math around, you know? It's like, derivative of sine 3 of x, k is 3. It's the derivative of the inside times cosine of 3x. So this is just the derivative of 3x, which is 3, times the derivative of the outside part. That's the inside derivative. Here's the outside derivative. And you could rewrite this in a couple of ways. I saw Addie put the 3x squared in front. You can make it pretty, but if you got that, you got it. That's the hard part. Is there any questions? Kind of moving fast, gonna get a little faster here. All right. What is the derivative? Now this one, kind of gonna leave you to navigate just based upon the things we've talked about. What is the derivative of the sine of e to the x? So it's the flip. And for this one, think the chain rule in general. It won't be exactly over here. We want derivative of f g of x. This is e to the x. That's your inside part right there. If you are done with that, and you might be, could you find its second derivative? So take the derivative of the derivative, you just, I'm gonna come around and see where folks are at. So what's the outside? Yeah, what's the derivative? So, yeah, so it's equal to cosine, and then leave the inside part alone. And then close it off, yeah. Now what's the derivative of the inside? What's the x derivative? So times e to the x. There we go. That's it. Perfect, yeah, your outside times your inside. Nice. Nicely done. Let me get back here, my friend. I haven't checked on you at all.
Yeah.
You want me to check on you? Oh, you're doing the.
Oh, no, yeah.
Yeah. So let's see, so. Oh wait, that's a different, okay.
Yeah,
you're
no,
doing-
this is, well, this is secondary, but.
It's secondary. I'm not sure if that's the second derivative.
Yeah.
I think, is this, oh, yeah, this might be your second derivative here. Oh, well, wait, no, because that's a product, right? So be, yeah, so that's what I was trying to
Yeah.
throw you off with.
Okay.
How are you doing? How you feeling about this? That is not right. Okay, cool, because you're doing too much. So the good news is you're doing too much, do less. So what's the outside and what's the inside here?
This is the outside.
What's the derivative? And you got the outside. So this, let's put an equal sign in front of that. So you took the derivative of the outside, you left the inside alone. That's beautiful. Times the derivative of the inside. What's the derivative of the inside? It is not. We don't have it up on there anymore. Where's that little table? Where's your little table? Okay, keep that out. Keep that out till you get good at knowing what these are. There you go.
Oh,
Mm-hmm.
so you just leave it?
No, so times e to the x, so it's cosine of e to the x times e to the x on the outside. And then close that off. Oh, yeah. How about we erase that line and come back here, because you were doing so good right here. Times e to the x. Or, yeah, no, not to there, no. No, it's good. So leave the cosine alone.
Okay.
On the right edge, put times e to the x. There you go. Because you were kind of treating this word cosine like it was a thing that you could, like a number. That's why, yeah, so it's not cosine times e to the x, it's cosine of e to the x. That's a times there.
Okay.
Does
Yeah.
that make sense?
Yeah.
So now let's try the derivative of that.
Okay.
Product rule.
Yeah.
Write it out slowly. You got this. You got this. Oh my God, how's it look? That looks right. Yes, indeed. That looks right. It's still not very pretty. Anyway. Oh, yeah, that's awesome. That looks good. That looks great. That looks really good. Yeah, I think so. Sorry, it ain't pretty.
No, that ain't pretty at all.
None of this stuff is pretty. I'm being brutal. That looks beautiful. Yeah. Yep, that's it. It ain't pretty, but you got it. Derivative of the outside. Leave the inside alone. Derivative of the inside. E to the x. Done with the chain rule. Now I've got to do second derivative. So the derivative, I'm going to write it out. I'm going to put the e to the x in front just because I kind of like it there. It just feels better to me. That's times. So this is a product rule. Derivative of e to the x is e to the x. Leave that alone. Copy it down. Plus this left alone, plus e to the x, leave that alone, times the derivative of this dude. And I'm going to actually write that out. So this is already done. This piece needs some work. This needs the chain rule again. And it's kind of like that problem up there, except I got that cosine. So let's copy some stuff down. Derivative of this, I'm going to use the chain rule. Derivative of the outside is negative sine. Leave the inside alone. Times the derivative of the inside, e to the x. And if we want to rewrite all this, and we kind of do, just a little bit, I'd pull that minus out in front. E to the x times e to the x is e to the 2x. Just add those exponents. Sine e to the x. I've got these like playful ones in my brain that I'm just not gonna pull out yet. We gotta be in the mood for playful derivatives first. We gotta like work up to it. Can't just be playful when we're figuring stuff out. So, what is the derivative of sine of cosine of 2x? I said the word of twice. Be careful. Go slowly, write it out step by step. Use the notation to keep your brain straight. Oh geez, I forgot about the natural log rule. We also had that one. We'll do that in a minute. very slowly. I'm doing my chains one step at a time. I think that's about as pretty as it could get, which isn't very better than some of the stuff we saw today. I'm gonna put a couple up on the board to give you something to practice on. That one can talk about this stuff, or I can give it to you individually and we can talk about it. Let me give you a few to do. Please find these derivatives. How do we write that one first? Was putting up a special case of chain rule up there. Might come in handy. That's a pretty good list to work on. That's enough right now. You should be letting me know if you need help. Make a little sound or something. Some kind of auction move. Let me check your work here, see how it's going. How'd this, where's that other guy? How'd that guy turn out for you?
Oh,
You
yeah,
okay
I
about
got
that?
the same, yeah.
Cool,
Right here.
awesome, cool. All right, let's see what we got here. So, oh yeah, and then you're doing these pretty fast. Yeah, that looks great. What does that say there? Is that,
I'm sorry, yeah,
no, it's okay, no sorries
Um,
needed, you never have to apologize. Oh, I see. So how did you do it though? Let's see, so,
It's, yeah, so.
Okay, I
took
think I see.
the derivative of this first,
yeah,
right? And then I took the derivative of this. But
Yes.
would you take the derivative of this and multiply it to the outside of whole fraction?
yes. So that
Oh,
three
okay,
actually
okay.
goes on top.
Yeah, so it'd be, -6 on top, right?
Correct, yes.
Oh, okay, yeah,
Yes,
that's the
yes,
only thing I was
uh-huh,
confused about,
uh-huh.
yeah, if, okay, so -6,
Yeah,
okay.
yeah, no, it's all good. Now that you need a sorry
Yeah,
for.
okay.
No, no, I'm just kidding. And then this, is that what's that operation between?
Times. Times,
Okay.
2x.
Jeez, well, you're going too fast. I'm gonna give you one. Now you're in trouble, because now you got private shit coming your way. Well, let's find. Yeah. Oh. Yeah, it's not
Yeah.
even that hard. Yeah,
Yeah,
let me give
okay.
you two. I'm
Okay,
gonna give you
okay.
two, because you probably, that wasn't what I was thinking. What I was thinking was this. And you're gonna have to look that up. Maybe you probably already know it, so.
Yeah, I'm pretty sure.
Um,
totally agree.
Times the group of the X system.
Where's the part where you left the inside a little?
Oh, it's.
There we go. That looks so much better. Yes, ma'am, I agree. And then this guy's kinda got a similar issue
Oh,
here.
yes.
That looks so much better, Andy. Yeah. Excellent, excellent. And then that bottom one looks great. That looks good. We'll work my way up backwards. Beautiful. Nice, nice simplification. Excellent. I feel like I haven't spent any time hanging with you today. Well, let's check. Okay, so let's see. Love that one. How did you do this guy? So let's talk about that guy. You're not sure? Quotient rule. Oh, I see, I see.
But I realize now that I forgot that was square at the bottom, so I see that, so that's not wrong. I did it without that right
Yeah.
square, so that one's wrong.
Got it.
I know how to fix it.
Okay, cool.
Yeah.
And another way, honestly, a little simpler than quotient rule
Mhm.
would be to write it as 3 minus x, or 3x minus
Closer
5
to
to
the
negative
second
2.
power, yeah.
Just a little,
Yeah, I think if I realized in my head that it was the second power, I would have done that.
Definitely,
But yeah,
yeah.
if for some reason when I read it, I didn't read it.
Yeah, gotcha. Okay, cool. So that makes sense that you
Yeah,
were using
yeah,
the
yeah,
quotient
yeah.
rule, and that one looks beautiful.
Okay.
Oh, no,
No.
something's a little off on that one. Check that guy too.
I see it now.
You see him? Okay, cool. Yeah, keep on cranking. I'm not gonna stop you. You're doing the good work, the painful good work. How we doing here? Yeah, I like it. I like it. How we doing? We'll find out, huh? That looks beautiful. That looks beautiful. Excellent. Solid work. It's a challenge problem. For those who have already given the okie dokie to. Oh, son of a. Why are all these pens so shite? It's just garbage. It's garbage. Where's the good one? There's a good one. This is, like I said, this is a challenge problem. Yeah, that's a good reaction. Eeks. What's the derivative of eeks? Just go slowly. This is one I was thinking about earlier. It's like, when are we gonna pull that one out? It just makes you be careful. It's not mean. It's just mean. Oh, come now. You've lived a very sheltered life, I would say, if this is feeling me. On this second one, if you're working on it, you might be tempted to use the quotient rule, which will absolutely work. But there's an easier way, and it's to rewrite it with a negative exponent. And that makes life way, way better. And it's just a power rule thing.
out. If you don't get a chance to work all these through today, just maybe make sure to work them at home and check the recording to make sure you get that practice in. Because those definitely, this is like exam style difficulty right here. If we can do this stuff, we can do the exam. I'm not gonna put, I don't do bullshit on the exams. I don't try to trick you or test you and push your limits, for God's sake. So this guy here, this is my exponent. So I'm gonna copy the original, leave it alone, times the derivative of the exponent. That's step one. Keep on cruising. It's a recursion. You just feed back. You like unravel it. So it's e to the e to the e to the x times. Now this guy is the derivative of e to that exponent. So I'm going to copy the problem. Problem just gets copied times the derivative of the exponent. And if you don't use notation, you might get confused. That's why it's really a good practice to get this guy out. Times e to the x, and then yay, we're all done. If you're and I see that we have some completionists in here, people in a video game who have to get all the achievements and stuff. The simplifiers, and I love you for it. If you enjoy things like that, you know, what the hell, why not? That's a weird ass problem. Is there anything, just like before I get any of that off the board, I'll probably leave it up, but is there anything y'all want to talk about? Asha, you're just stretching. Yeah, she's
No,
stretching.
what'd you do with the 5?
Ah, cool, you do have a question, awesome. Are you talking about this guy here?
Yeah,
Or the top one? Bottom one.
No,
Oh,
that
this guy here. So first step was I rewrote it like this. Does that sound okay to you?
Yeah.
Cool. All right. So let me kind of just work it through. So now the outside is that thing raised to the negative second. In some ways, it's like I'm differentiating the parentheses. So I just bring the exponent out front, leave the inside alone, and decrease by 1. So that's the outside derivative. See, if I didn't have that in there, if it was just x to the negative second, it would go to negative 2x to the negative third. You see that rhythm right here. Does that sound good so far?
Yeah.
And then times the derivative of the inside, 3x minus 5. So now I've just got to do this, and the derivative of 3x is 3. 0, the 5 goes to 0.
Oh.
So I think that's what you were asking about, is that
Yeah.
correct? Yeah, and then the 3, which is a weird ass looking 3, I just made that negative 6. 3x minus 5. Does that help? Cool. Any other questions? So I didn't forget we have a quiz today. I didn't forget that, even though you were proud. I knew you were hoping. I could hear the thoughts. He forgot. No, he didn't forget. Let's just do it. Get it done with. It's gonna be so easy compared to this shit. There's no chain rule on there. There's no product rule. There's no quotient rule. It's all power rule. Do not use any other rules except the power rule on this quiz, okay? I know your brain is swarming with other ideas. I'm gonna keep it chill. So I would just like you to find the derivative of each expression. The first one is x cubed plus x to the negative third. So some of you have probably done like already. You're probably doing that one in your head. That's okay. Number 2 is 1 over x plus the square root of x. The last one is 3 over x to the 5th minus 2. And then, please give me a graph of sine and cosine. That's low hanging fruit there, hopefully. I didn't even ask for a tangent line equation.